This is a production of Cornell University.
Sorry. So in grapes, so two of the major diseases. First one is powder mildew, and the second is downy mildew. So if you walk in the vineyard this time of the year, you can easily see this sort of some of these symptoms, like in the vineyard, and these are the major diseases in the grapes. So far, these diseases are managed by using the fungicides. But we have seen the cases where fungicide fail to act. There are some of the fungicide with different mode of action like DMI and QOI. We have found the isolate that can tolerate this fungicide. So there is a recommendation to use a tank mix or different kind of things. So the threat is coming. So that gives a sense we have to think about alternative ways to manage diseases. So we have been using UV for many of the other diseases. But for the sake of the time, I'm just presenting data on downy mildew today. So before jump into the data, I'd like to give you what is UVC in the solar radiations. When you see the UVC is close to the visible range, but with a shorter wavelength, with high intensity shorter wavelength. UV itself is divided into three different, UVA, UVB, and UVC. UVB and UVA, they reaches to the surface. UVA is part of the, it constitutes the part of the photons. UVB, there is some interaction with the humans, plants, animals in the Earth's surface. However, UVC is blocked by the stratospheric ozone layer, so it does not reach to the Earth's surface, which gives us a fantastic candidate to study its interaction with the plant as well as plant pathogenic pathogens. So the UVC have the germicidal effect, and this makes it excellent candidate to study effect on plant pathogens. But the germicidal effect of UVC is nothing new. People have been using UVC for a long time to sterilize things. In fact, the eggs we eat every single day, it comes after sterilizing with the UV. So in our case, we use in the lab, we build up a UV tower. Maybe many of you have seen this. It consists of UV lamp on the top, has a sorter to control the UV, and has a structure where you can put the samples and varies the dose or the irritants that you receive for each samples. So the lamp, it has the capacity of irritants somewhere close to 25. The same thing we try to replicate in the field. So in the field, we use a device called Thorvald. So this is an automated robot developed by Saga Robotics based in Norway. And it has a GPS system on the top and that it controls automatically. So it goes above the trellis and applies the UV. So we use these two systems to study the effect of the UV. So the first thing I ask, where is the UVC? So when I say UV, here is UVC. Does it really work or not? And the question is, and the answer is yes. So what you can see here is the effect on the same leaf. This is the third leaf from the top of the shoot from Chardonnay grapes. When you see this, if there is no UV, you can see very good growth of the downy mildew. And if you apply the UV, there is no growth of the downy mildew. And in this case, we applied like 200 joules per meter square. After application, we put like around 4 hours after darkness, and then we inoculate with the downy mildew. See the very obvious phenotypes. So one thing I want to point out here is this. So this is not the germicidal effect we are doing here. So we are not treating the downy mildew. What we are treating is we are exposing the UV to the grape leaf, and then we're seeing some sort of resistance induced. So it's like a pre-inoculation UVC application. So this is fantastic. In one way, it's very obvious. But in another way, it was tough for me. I had so many YTC2 project going on, and all of a sudden I see these phenotypes. But like as of you, if we see the phenotype like this, we can ask multiple questions, what's going on here? So the second question I ask right away is, how much UV do we really have to apply? Because we want to find a fine balance between the amount of UV we can use to induce resistance and the UV that doesn't do phytotoxicity to the plants. So I varies the doses of UVs ranges from 200 all the way to 47. And from here, you can see if there is a UV dose somewhere close to 100, there is a significant decrease in the number of sporangia produced in the leaf discs. And the picture from the down, you can see clearly there is like a quantitative variation based on the dosage of the UV we applied on the grape leaf. So very interesting. Second question I asked is, which side of the leaf do we need to treat? In the beginning, I unintentionally or intentionally, I applied on the bottom surface of the leaf, and that came with the idea, I know the downy mildew growth on the bottom surface, but how about if we treat on the top surface and inoculate on the bottom surface, do we see the same effect? And the answer is no. So the side we treat matters. So here you can see if we treat on the bottom surface, we see fantastic control. In this case, we use 200 joules per meter square. But if we treat on the top surface, no, we see there is enough growth on the downy mildew. So the side we use UV treatment matters. Another question I asked is whether the resistance is spread or is more like localized. So if we treat on the particular spot, it's going to stay there or it's going to spread. So from here, you can see I use different doses of the UV on the same leaf. So start from 0, goes all the way to 200, and you can see in the 200, there is almost no growth. But going from 0 to 200, you see some sort of variation. So there is, like obviously on the 0, there is lots of downy mildew growth, but if you go 50 and 100, there is some sort of a reduction. And again, this picture shows if we treat on the bottom side, yes, we see some control, but on the right, you can see if it is on the top side and inoculate on the bottom side, we didn't see any effect, or we didn't see any resistance induced. And I was interested how long the resistance hold. So do we have to treat one time, or do we need to treat weekly, a couple of times in a week, or we didn't have to treat many times? So this is another question I asked, and when you see it, here the resistance holds more or less close to week. So the resistance induced holds almost close to like 7 days, but it's hard for me to keep the leaves after 7 days. Just, here like I inoculate for like this day, wait for 7 days. After 7 days, you inoculate with the downy mildew, and then wait like 4 days to see the symptoms. So that's a window of like 10, 12 days. And that's enough time to keep the leaf survive. I like to know the ways where we can keep the leaf longer and see what the symptoms looks like. And from the figure on the right, you can see this varies with the dose. In some of the dose, like in a 200, you can see the early response, but in 100, the response is a little bit slow. So it holds like for a while. So it was fantastic. It's a detached leaf. That's the limitation, but that's not the case if we want to apply the UV in the field. So we need to know what will happen if the leaf is intact, or if we apply the UVC in the vine itself. So that's another question we asked, and we see the similar replication in the field. So what we did, we went there weekly and applied the UV with 2 different doses, 100 and 200. And here you can see that we are assessing the downy mildew severity on the leaf. And then we have 4 different treatments: fungicides, untreated control, UV dose of 100 and 200, and with just 100 and 200, it's more or less perfectly matching my result from the labs. Like if we apply the 100 and 200, you get significant decrease in the development of downy mildew, and very close to fungicide. So this is very promising. Oh, there is fantastic control of downy mildew on the leaf, but if we go in the cluster, let's see, we check in the cluster. So cluster is not so much as leaf. And so there is some sort of reduction in the cluster, but not too much. And there is so much variation. When you see the distribution, is so much variation. And there could be a number of reasons behind this, because when we apply the UV, last year we used a different system, whether how much of the UV really get in the cluster itself. And And in grapes, the clusters are immune to like only short period of time. And after that, it develops some sort of ontogenic resistance. So whether we catch that time period or not, that's the second question. So there is a difference in the cluster and in the leaf. So, but we also like to know whether there is an effect on the plant growth and physiology. So we went every week and measure the growth in terms of leaf expansion, leaf length and width. We measure some physiological parameter with this phytosyn Q, some photosynthesis efficiency, the chlorophyll content. So when we say here a time, it goes from like almost like 2 months in an interval, and we measure the growth and photosynthesis, and you see the pattern is follows the more or less same pattern. There may be in a couple of cases we see some differences, but in the majority of the cases we see the same pattern between the UV applied and unapplied. So this is fantastic. So my take-home message is if we do a pre-inoculation UVC, we can protect against the downy mildew. We have the data, the direct germicidal effect of UVC on the powdery mildew as well as sourrot. That's I also want to point out we are repeating this experiment this year and see what we're gonna see. But however, we don't know many things. There are so many things we don't know with the UVC. We don't know how this impacts other diseases like botrytis, black rot, comopsis, anthracnose. Those are important diseases based on the different locations. We don't know how it impacts on the enological traits like yield and berry chemistry or berry composition. By pilosphere composition on microbiota, we don't know how it impacts. And if fungicide change the microbiota, I mean, it's not surprising if the UV changes as well. And we don't know how it impacts other varieties of the grapes, as well as on the different plants, how the UVC, whether it induces some sort of resistance. With this, I'd like to thank many people involved in this. This is like a teamwork. David Garrity, my PA, is the one to lead this. Saga Robotics, they are the one to develop the automated robots. RPI, Lightning Research Center, they are based on the light. They do all the lightning. Cornell Agritech, Lance Carter Davidson, and the USDARS, as well as the funding agency. I'd be happy if there are any questions. But I also recommend you to raise to David Garrity if you have any questions on the UV. Thank you.
Excellent. Thank you, Surya. We have a minute or two to answer a few questions. First of which, a question, did you have any biochemical analyses or gene expression to check the resistance induction? And also, are there physical modifications on the leaf surface?
So the first question, I'm sampling the leaves for RNA-seq analysis. So far we don't have. There are a couple of papers people did previously, and they have seen some sort of expression, changes in the gene expression. But for my particular result, we'll have to wait to see. The second question, we didn't see, so that varies on the dose. If we increase the dose and go higher than 200, we see some sort of phytotoxicity. It also depends on the leaf. In the field, we didn't see any sort of phytotoxicity.
This has been a production of Cornell University, on the web at cornell.edu.